Welcome to part 1 of Competency 14 quiz. In this video, we will work with probability distributions. Number 1, consider the following probability distribution. What is the mean value of this distribution? Okay, the first thing we need to do is create a list in L1 and L2. Okay, so anyway, that's what I'm going to do. Now, if you have to, oops, sorry about that. Wrote the wrong one. Okay, we want L1 here and L2. But if for some reason you have to, you can put it in 2 and 3 and so on. But let's go ahead and push data. Now, all 3 of my lists are populated with other numbers. What do I need to do? Push data again, arrow up, see where it says number 4? That's my all clear. And now everything's ready for me. Okay. So X is L1, which is just a good habit to get into. Okay, so 0 and 2, 4, 6, arrow over, and I need 0.5, 0.2, 0.25, and 0.05 enter. Verify they match up. Looks good. Okay, now, all right. Yes, you can push second data to get your stats. We need the stats next because we're going to get the mean. But be careful. Sometimes the calculator will put the data down at the bottom in that cell that you have. Like I have the first cell of L2 highlighted. So be real careful with that. It's always best practice to say second mode to back all the way out and then second data to get into your stats. Now listen, we are not doing a var, a two variable. This is not a two variable. This is a situation of a one variable and a frequency. Okay, so you need number 1. All right. So I have data in, I know it seems strange, but L1, I mean, L1 or list 1, that's highlighted correctly. What we need to do now is go down and go over all the way to L2. Push enter to highlight that. Okay. Now let's calc. Okay. And looks like we have the correct mean. Now remember, this would be X bar, which is number 2. Let me go down. I'll arrow down. That's what we want. That is actually the mean from our data. The calculator shows a little differently. Okay. And we have less than 5 pieces of data or data points. So look at the error it gives us on this sample. It's really small. Okay. All right. Now let's look at number 2. Number 2, yes, we will definitely do the same thing. Okay. However, there's a little something I need to show you. Okay. Just in case. All right. And again, it says consider the distribution. What is the variance? Okay. They want the variance. You may not be familiar with variance. Okay. So we have your standard deviation, and that is this little symbol here. That's my sigma. Variance is my sigma square, okay? But on our calculator, it's going to look a little different, okay? All right. So let's go ahead and push data to go back. And I'm going to push it again and clear everything out. So go up number 4. Okay, just to start fresh. So 1, 2, 3, 4, 5, arrow over. Okay. And now I want, okay, and I'm going to have to, I can't put in fractions. See, I can put the fraction symbol on. So probably the best way to do this is 1 fraction symbol, 12 enter. Okay. That way it keeps the fraction. Okay. Let me show you the difference if I do it differently. 1 divided by 3. Instead of using the fraction, I use the division symbol. Watch this. It changes it to a decimal. Okay. It does make a difference in some situations. So I'm going to say 1 fraction 3, enter. Okay. All right. So 1 fraction 6, enter. 1 fraction 4, enter. And 1 fraction 6, enter again. Okay. We have it set up. So we need to get our variance. Now, how do we do that? This is kind of a tricky thing. Not everybody knows that the calculator would do this. And I just keep playing around on every kind of calculator I can to figure out every little step I possibly can get. Okay, so I need second mode for safety's sake. Now, second data. All right, we need 1 var. Okay, everything is set up the way we need. So I'm going to enter till we get to calc. Okay. All right, so I need you to arrow down. Okay, I need you to look at what number 4 is. See the difference between, okay, we aren't doing a summation. We need number 4. Number 4, if you look, it does have sigma x. This means it's the sample, it's the sample deviation from our info. Either way, whatever it means, doesn't matter. It's what we want. But notice we don't have a variance for that. What I need you to do is see we're highlighted on number 4. Press enter. Very convenient. Now you're going to say, well, if that just gives me the variable, the symbol, okay, what this is trying to tell me or tell us is that I have your information. I'm saving it right now. What do you want to do with it? Okay, I want to square it. And I push enter. Okay. Now you may say, well, that isn't quite what I want. But notice that the denominator is correct. Our ABCD options are mixed numbers. What do? We simply change it to a mixed number. So that would be above our scientific notation button. So second scientific notation. Now, above it's what we need. See how it says fraction to mixed number? Notice that's what I know it's a little hard to read, but that's actually what it says. It says change this fraction, which is n over d, numerator over denominator, to u for whole number and a numerator over denominator. Okay. All right. So let's push enter. Okay. And there we go. Option A. That's just a little bit of convenience that you can take a look at. Let's look at it one more time. Second stat 1 is what we wanted. Okay, see there? It's all set up. Okay, now let's go back down and make a note of what the number is. Okay, and let's enter. Okay, now I'm gonna push enter again. And look, it gives us the number back. So if you want to go and do something else and you're like, okay, wait a minute, I need to see that number on the main screen. I've got other stuff I'm doing. Well, you can go ahead and pull that value. In fact, you can do this with any of those values. All right, let's go to number 3. Number 3, which one of the following is not a requirement for a binomial experiment? Okay. Now, let's think about this. If you remember, a binomial experiment is about successes and failures, okay? And there were some certain properties of those successes and failures. So let's read through and see what we have. A, each trial is either labeled as success or failure. Yep, that's a check. So we don't want that. Okay. The probability for success is the same for each trial. Oh, it has to be, or it won't work, like a dice or a coin. Okay. you have to have the repeated probability. Okay, so that's not what we want. Okay, let's look at C. The probability for success equals the probability for failure on each trial. Now, you might think that, but that's not true. Okay, it says the probability for success equals a probability for failure. No, the probability for success must be the same in each trial, but failure and success don't have to be the same thing. There are situations where failure would be more likely than success, and vice versa. So I would say C is what we need. But let's take a look at D. Each trial is independent of the other trials. That is a requirement. Okay. All right. So this kind of gives you a review of it. If you're still a little shaky on binomial experiments, it's a good idea to brush up. At the middle school level, we talk about these things some, okay, but we don't say the vocabulary, the in depth vocabulary. We don't go through the in depth situations, okay? But as an educator, you are responsible for this information and you should be able to pass the test with this information. Okay, let's look at number 4. An ordinary die is rolled 5 times. What is the probability that the number 3 will show exactly once? Okay, don't be fooled with the fact that they said 3 here. And there's a reason why they spelled it out and didn't write it. Okay? All right, so we need to know a few facts here. Okay, so we need to know N. Well, that's the number of when we want to see it. Okay, and it says once. We're not asking to see it 5 times or 6 times or whatever. Okay. So N is 1. Probability. Okay. Well, a 3, the probability, okay, we're talking about an ordinary die and the number 3, well, that's going to be 1 out of 6. Okay. Now we need the number of trials. That's 5. Okay. Now, please be cognizant of what the expression is. You should be able to say what the expression is. So, what is that? Number of trials, combination. We only want one of them times the probability. We only want that to be seen once. So, N is 1. That's capital N. Remember now, not happening is 5 out of 6. And remember, that is N minus, remember, it's N minus capital N, small n, number of trials minus the desired attempt or desired success. So that would be 5 minus 1 is 4. Okay. All right. So we're going to put all that in the calculator. All right. So type your 5 first, then prob. You want number 2, now 1, and times your fraction 1 out of 6. Go all the way over. You got to arrow over. Now we need, well, we don't need anything because all numbers and fractions, all values are an understood 1 exponential. Okay. So leave it blank. All right. So then we need our parentheses and our fraction 5 out of 6. Arrow all the way over. Close your parentheses. Now you need caret up 4. Okay. All right. Let's push enter and let's see what that gives us. The way that they've rounded, it would be option B. Well, actually, the others aren't even close. Okay. All right. So let's look at number 5. Okay. It says Which one of the following statements is not necessarily true? All right, let's read through them. All right, it says A, two normal curves with the same mean have the same standard deviation. That is not always true. In fact, there was a question, I think it was maybe at the beginning of the last video, where we saw three normal curves all compared with different standard deviations, and we had to put them in order. So this one's, I'm going to say, is it. It's not necessarily true. But let's look at B. The mean, median, and mode of a normal distribution is equal. Oh, yes, that is definitely a property. So that's true. We don't want that. You remember the picture that you saw at the first of this video, and I drew I drew the image of the normal distribution. That was one of the properties. We've got our z-score is 0, and is where the mean, mode, and median are all equal. Okay, now let's look at C. The area under the standard normal curve is 1. Oh, yeah, definitely true. You need to remember that. That's something you've got to remember, because if you have 90% all, on one side of your curve, the majority of the curve, you have to figure out what the rest of it is. 90% may be what you're looking for. Well, what's the rest? What is the other 10%? Okay, or it may be the 10%. It may be on the left tail, the first 10%. Well, then you have to figure out what the other 90% is. Well, the fact that it equals 1 really helps out. Let's look at D. The normal curve does not intersect the x-axis. Absolutely. It does not intersect. It just goes on forever. So on the ends, the two ends, those tails, we're guessing a lot. Okay. All right. So we just know it's there and it works, and that's what the distribution should look like. But there is no, it's just less and less and less. Okay. So you can have teeny, very, very small confidence level. I mean, you can have a really great confidence level, if you understand what I'm saying. So that's kind of something unique to wrap your head around, but it's true. Okay. All right. Okay. This is the last question in this video. Thank you for liking, subscribing, and sharing, and making it to the end of the video. I hope it was helpful. Happy testing, everyone.